Okay, today we're going to start with an activity. Now, this activity is going to be a little tricky because there isn't actually anybody here. Uh, Usually, obviously, we're doing this in a class full of students, and we can get some back and forth and some people voting and guessing and maybe arguing a little bit or disagreeing, that kind of thing. But unfortunately, right now, we don't have that luxury because I'm just doing this video on my own. But I'm going to kind of walk you through the activity anyway, get you thinking a little bit on your own, hopefully. And if you want to pause at any point, if I'm going too fast and think about it and come up with your own guess or kind of figure things out on your own, that's absolutely fine. That's a great idea. I would encourage you to do that. So the activity looks like this. We've got two lines. They're going to be labeled A and B, and you have to decide which one is steeper. Now, you're not allowed to touch them. You're not allowed to hold a pencil up to them or your finger up to them or anything like that. Again, usually you're in a room and this is up at the front on the projector screen, and you're sitting in your desk far away, and it makes it even that much harder. But I do find that usually people have a guess of which one they think is steeper, but not everybody agrees, and some people would say A and some people would say B. And even if you're very confident, and you may be a visual person, so you might find this easy, and you might be able to tell which one actually is the steeper one in this case, that's fine. But you can imagine that if they were very close in steepness, it would be really hard to tell. So my question then is, what would help us prove which one's steeper? What would help us determine exactly um, sort of would give us a hint or tip or make it easier for us to determine which one's steeper. Prove it without a doubt, or at least make it easier for us to figure out um, with good confidence of which one's steeper. Okay. And some people even come up with this, but even if you didn't, what if I gave you a grid like this? Then how would we be able to tell which one is steeper, right? This allows us to actually do some calculations and determine the steepness of each of these. So if you want to pause here and think about how you can use this grid to actually compare the steepnesses, I would encourage you to do that. I'm going to go ahead and walk us through this so that we can figure out which one's steeper. So I'm going to start by figuring out how tall each of these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that has a height, a straight up height of 11, whatever meters, centimeters, doesn't matter, okay? And what about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So look at that. They're both the same height. Does that mean that they're the same steepness? One way that I like to think about this, and if you're not a skier or a snowboarder, then maybe it doesn't quite work for you, but even if you've ever been on a toboggan, or if you can just imagine doing any of those things, let's say you're at the top of a hill, okay, or you're top of a mountain, and you're about to ski or snowboard down it. Well, from the top, they have different difficulty of runs. They have some that are hard because they're steep, and they have some that are easier because they're not as steep. But all those runs are the same height. They're all starting from the top of the mountain. So just the height doesn't tell me how steep a line is. What's the other thing we have to figure out in order to determine how steep a line is? Well, I have to see how that change in height, how long that takes horizontally. So 1, 2, 3, 4, 5, and 1, 2, 3, 4. So A goes up 11, let's say meters, and it takes 5 meters to do that. B goes up 11 meters, but it only takes 4 meters to go up it. So B is steeper because it kind of goes up or down, depending on how you're looking at it, faster, right? It doesn't take as long horizontally to go up or down the 11 units, the 11 squares as A. So in this case, B is steeper. Okay, let's try another one. Aha, everybody thinks they're really good at this. This one's pretty tricky. Which one is steeper? Why is this one harder to tell? They're different lengths. Does that mean B is steeper because it's longer? Or A is steeper because it's shorter? And I hope that you understand that the length of a line doesn't have to do with its steepness. You could have a hill that's really short but really steep, like a cliff, and you could have a hill that's not steep at all, but is quite tall and just goes really, really gently down. I mean, think about driving your car. You go over a bump that goes down really fast, so it's steep, or you go down a long hill on a highway that's really, really gentle, right? So the actual length of the line or the height doesn't have anything to do with the steepness. So again, what do we need to compare these a little bit better? Well, having a grid will help. And this one is going over 2, up 1, 2, 3, 4. And this one's going over 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that was 6, over 6 and up 12. And A was over 2 and up 4. So now, which one is steepest? Well, it was easier, I guess, for the first example because they both had the same length that they went up or down. And then I just had to look at that horizontal distance. In this one, they don't have the same anything, so how am I going to tell? And I'm going to wait a minute for you to think about it and see if you can come up with something. And hopefully some of you have noticed that both of these are actually the same. And I can look at that in a few ways. One of the ways is every time I'm going over 2, I'm going up 4 for A, but that's the same for B. If I go over 2, I go up 4. Over 2 more, up 4 more. So they're actually the same. And I could boil it down even further. Every time I go over 1, I go up 2. Over 1, 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 up 2, and so on. And now I can see that both of these actually have the same slope. And don't worry too much about this yet, but eventually we will look at slopes kind of like fractions. And if you remember, reducing a fraction to its lowest terms, 4 over 2 would become 2 over 1, and 12 over 6 would also become 2 over 1. And we can see they're both the fraction 2 over 1, and so they actually have the same measure of steepness. Let's try another one. Ooh, this one's trickier again as well, although there's always people who think they know the answer and people who get it for sure if they're good at this kind of estimation or visualizing. What makes this one harder? Of course, they're slanting in different directions. But one can still be steeper than the other. So let's do this quickly. 1, 2, 3, 4, because hopefully we're getting the hang of this. And 1, 2, 3, 4, 5, 6, 7. Going to put it in there. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 and 6 or 7 and 4. Gee, which one is steeper? It's still not obvious looking at those numbers, I don't think, which one is steeper. Now, this is something we're going to look more at down the road, so we're not going to worry too much about that yet. But we'll get there eventually. And like a lot of things, there's a couple of strategies that you could use. If I think about A as the fraction of 7 over 4, and I think about B as the fraction of 11 over 6, then one thing that I can do is turn them both into a a fraction with a common denominator. So my common denominator would be 24 in this case. So I'm going to go times 6 and times 6. And just bear with me for a minute if you think you're not following. Let me finish this and you'll see why I'm doing this. 7 times 6 is 42. 4 times 6 is 24. Okay. And for this one, I'm going to do times 4 and times 4. And doing this kind of comparison is not something we're going to do a lot of, so don't worry about this. This is something we know how to do, is getting a common denominator with fractions, but it's not something we're going to be doing a lot of. So that's why I'm just kind of doing it quickly and not worrying too much about explaining what I'm doing. So this is 44 and this is 24. And now if I compare these two, I've got 42 over 24 and I've got 44 over 24. Well, now I can see which one is steeper because they're both going over 24, so they're both going over the same distance, but one of them is going up further. So if I go up further in the same distance, then that means I'm steeper. So again, in this one, B is steeper. Okay. We're going to do a couple more. You're going to notice, so I'll let you decide which one you think is steeper between these two. I'll give you a moment. Okay, then let's take a look now. I've already done it, but we would do the same thing. Now that you have those numbers, and this is A and this is B, which one is steeper? They're both going up the same amount, but one of them does it in 2 squares and the other does it in 3 squares. So in this case, again, B is steeper. Okay, and one more. Which one is steeper? Once again, I've got my A and my B, and I've already done the counting for us this time to speed it up a little bit. This time, they've both gone over the same amount. So in the same horizontal distance, B goes up a little bit higher, which means once again, B is the steeper one. Okay, so that's just a little activity to tie us into this idea of steepness. We're going to do a bit of a lesson on it now, but hopefully that helps get your mind thinking about the idea that there's two parts to measuring steepness: how far I go over and how far I go up. And the reason why we need two parts, again, is because I might have, let me see, just going up 12 isn't good enough comparing it to 4. I have to know how long it took me to go up each of those heights. And what if the heights that I go up are the same? That doesn't mean they're the same steepness, because if it takes longer to go up the same height, that's less steep. So we're seeing that there's two parts to measuring steepness. That's really the point of this activity, is understanding that there's two parts, and you have to be able to look at both and compare both to really understand the steepness of something. Okay, so we're going to do a bit more of a formal lesson here, and there's two important skills that we're going to talk about that you're going to practice, and there's one other really important idea that we are going to talk about that's going to help us always be successful with measuring the steepness of a line. Okay. And if you may have thought of this already, but the steepness of a line is related to the change. We talked about change, the two important parts of a linear relation. Where does it start and what is the change? And the steepness is directly related to the change in the graph. So this, although it seems different what we're doing today than what we've been doing, it's actually not. It's very closely related. Okay. So there are different words that we use to talk about the steepness of the line. And in fact, in grade 9, the word we're going to talk about today isn't necessarily the one we use the most, but it is one of them. And then in grade 10 and 11, it is the word you'll probably use more. But the measure of steepness of a line is called the slope. Okay. We also call it the rate or the change or the rate of change. Okay, and that's some language that we're maybe even going to use more of, but it's also in math called the slope of a line. Okay, and that's the slope of the line is telling us how steep it is. And we're going to get used to using numbers so that we can compare them. Okay, as we already discussed, there's two measurements that are required. And the overall slope or steepness of the line is the ratio of how high you're going over what distance. So that vertical change over the horizontal change. Okay, so we're going to pick 2 points on this line. I'll pick this one and this one. But notice that there are lots of other, this is what I was talking about before. There are lots of other nice points. That's not a good point. I'm not going to pick that one. I'm going to pick this one because it's where the grid lines meet, or I could have picked that one. But I picked the 2 blue ones, okay? And the slope of a line is equal to this distance, which we call the rise, and this distance, which we call the run, and it's the ratio of those two. So it is the rise over the run. That is the slope of the line. And this is something that you want to really remember, that that idea right there, rise over run, rise over run, rise over run. Say that over and over and over again to yourself so that you remember that the slope of the line or the rate of change or the steepness of the line is rise over run. Not run over rise, the order matters. It's always rise on top and run on bottom. Okay, one other little idea here. We'll get used to this, so we're introducing it today, but we'll keep practicing with this, and it's just a matter of remembering which one's which. A slope is positive if it looks like this, and a slope is negative if it looks like this. And we already talked about the idea of a line that looks like it's going up compared to a line that looks like it's going down. Okay, and both of these lines are kind of like a line is going up one way, but is going down the other way. So it can be a little bit confusing to talk about a line going up or down unless I put an arrow on it. But what if I put an arrow on it like that? Looks like it's going up. That's still a negative slope because it's sloping down to the right and up to the left. And that's what matters, okay? And we've seen this before if I had a rule. So this isn't what we're doing today. Don't worry about it too much. But if I had 5 plus 2x, or if I had a different rule, 4 minus 3x, and I can see that it's the minus sign that makes it negative, or the plus sign that makes it positive. And if I was looking at the table, I would see that as well, right? So we have talked about this, and that's the idea of positive and negative, but we actually call the slope positive or negative as well. Okay, so we've got slope as rise over run. We've got a positive going up to the right and a negative going down to the right. And those are the ideas that we've got so far for slope. And now we're going to do a little bit of work with slope. Okay, so we're going to determine the slope of each line. These are going to be some good examples because we're going to go back and see what I mean by finding nice points. When I look at this, what some people are going to do is they're going to try to use the ends. Not how this works, okay? I can use any 2 points on the line, and I'm going to start on the line, and I'm going to follow it until I find a nice point. In fact, let me zoom right in here and take a look. Here's all the places that the line kind of crosses through areas. That one's not even close, but that one kind of is. But look at how it misses, okay? So I can't turn that into a point like that. That's no good. That's no good, no good, no good. But this one's good because it crosses through perfectly. Okay, crosses through the grid lines where they meet perfectly. And this one right here is good because same thing, it crosses through the grid lines perfectly. So you have to look along that line and find two perfect points. And what is slope? Slope is rise over run. So I'm going to figure that out. So 1, 2, 3, 4 is my rise. And 1, 2, 3, 4, 5 is my run. Whoops. 5, I think I said. And slope equals rise over run. Now, eventually you're not going to have to write this down every time, but I do encourage you to do it now because you got to remember rise over run, rise over run, rise over run. If anybody ever says, I can't find the slope of this line, I'm going to say, well, what is the slope? And if you can't tell me that slope is rise over run, you're not thinking along the right lines. And so that's a rise of 4 and a run of 5. So the slope is 4 over 5. Slopes are fractions. Don't be scared of them. It's the work that we do with them isn't hard fraction work. So don't be too worried about that part of it. Again, it's the ratio of how far you're going up in the time that you're going over. Okay, same thing. I'm following along. Oh, there's a good point there. There's another one there. Keep following. There's another one there. So this time I've got 3 points and I could pick any 2 of them. And in fact, I'll show you how both of these, if I pick any 2, it'll work and give me the same answer. So let's say I pick the 2 that are furthest apart. I'm going to do the rise and the run. 1, 2, 3, 4, 5, 6. That looks like. So it's got a rise of 6. And 1, 2, 3, 4. A run of 4. So slope is rise over run, which is 6 over 4. But we like to have reduced fractions. So what if I did it this way instead? What if I did 1, 2, 3, a rise of 3, and 1, 2, a run of 2? Okay, well, that's the same as 6 divided by 2 and 4 divided by 2. Whoops. So that's the same as taking this slope and putting it in lowest terms. That will give me the same slope. 6 over 4 is the same as 3 over 2. And in fact, this is something I didn't talk about before. 6 divided by 4 is 1.5. And 3 divided by 2 is also 1.5. So that's another thing that we can look at is they give you the same decimal, right? So I use 2 different points. I used 2 points that were further apart and 2 points that were closer together. But in both cases, I actually got the same slope. They look like different numbers, but they are the same. They both mean 1.5. The 3 over 2 is the one we like because we do like it to be in lowest terms. But again, we're not going to worry too much about that right now. If you want to pause and give this one a try on your own, that's a great idea. Again, we're going to look along. I'm not using the ends of the arrows. We don't really use the arrows. We ignore those and we look at the line. So here's a point. Following along, there's another point. But I skipped a whole bunch of other points. But the idea is you can use whichever points you want. So from here, I'm going up 1, 2, 3, and I'm going over 1, 2, 3. So slope is rise over run, which is 3 over 3. And if I want to reduce that, that's 1 over 1 or just 1. And again, I could go over 1, up 1, which is a rise of 1 and a run of 1. Over 1, up 1, over 1, up 1, over 1, up 1. I can do the same thing over and over again, or I could go over 2, up 2, over 2, up 2, or over 3, up 3, right? It's all the same thing. It's just if I go over more, I have to go up more as well. If I double my overs, I double my ups. Okay, one more of these kinds of questions. Let's see if we can find any nice points. That's one. no good, no good. There's another one. Okay, continuing to follow along, there's another one. And so if I think about all of these, I'm going uh, down one, over 1, 2, 3, down one again, over 1, 2, 3, okay? Or down 2 and over 6 would be the same thing. Going over 3 twice is the same as going over 6. What do we notice about this one? Actually, we skipped it about B as well. This is the idea of positive and negative slopes. So this one's going up to the right. This one's going down to the left, down to the right, sorry. This one's going up to the right, and this one's going down to the right. Okay, so my slope is going to be rise of 1 and a run of 3, and it's going to be negative. And some people do think about it this way. I think it can be troublesome, but when I go over 3, that's like a plus 3. And then when I go down 1, that's like a minus 1. And minus 1 over 3, right? But I just think about it, is it going this way or is it going that way? I think that's the easiest way to think about it, and just remember that this one's positive and this one's negative, okay? Which means we skipped it on this one because it's going down to the right, which means both of these should be negative because that's a negative slope, okay? So that is given a line determining the slope of the line by counting the rise and the run and putting them in a fraction properly. This last activity is drawing a line with each given slope. Some people find this one hard because they don't know where to start, but it doesn't matter. You can start wherever you want. The other thing is we're introducing a new idea here where this is not a fraction. It looks like it's just a number, and everything we've done is talking about slopes as ratios of numbers, fractions, okay? So what does that mean? Well, this introduces or reminds us of an important idea that any number that's just a whole number is over 1. So in this case, I've got a rise of 3 and a run of 1. And remember I said slope is all about rise over run. So if I'm given the slope, I want to turn that into the rise and turn that into the run. And then I pick any point on this grid. Actually, I'm going to start a little bit lower. And my rise is 3, so I'm going up 1, 2, 3, and then over 1. And I'll do it again. 1, 2, 3 over 1. And it looks like I could fit one more. 1, 2, 3 over 1. Okay. And you don't have to do more than 2 points. You have to do at least 2 points. But if you do a couple more, you're probably going to get a better line. So it's not a bad idea. And again, we're not just connecting the dots. We are drawing a line through all the dots, so we don't have to go dot to dot. You can just go straight through them all. Okay, and that's how you draw. You should be using a ruler. That's how you draw a slope, draw a line when you're given the slope. Okay, this one's the same. -4 is -4 over 1, which means I have a rise of 4 and a run of 1. But what's different about this one is it's negative. So I'm going to start over here. And when I go over 1, because that's my run, I'm going down 4. 1, 2, 3, 4. Okay, over 1, down 1, 2, 3, 4. Because this will give me the right slope going down to the right that I want for a negative slope. Over 1, 1, 2, 3, 4. Get my ruler, connect them nicely with my ruler. A couple more. Now here's the fraction ones that we're used to. My rise is 1 and my run is 2. So I'm going to start here and I'm going to go up 1 and over 2, up 1 and over 2, up 1 and over 2 again. Okay, and finally, again, this one's negative. My rise is 3, and my run is 4. You pick the point where you start. In this case, I'm going to start up here, and I'm going down because it's negative. So I'm going to go down 1, 2, 3, and over 1, 2, 3, 4. One more I think we can fit. 1, 2, 3, 1, 2, 3, 4. Okay, let's say I missed that one. Let's say I miscounted. What's going to happen here? I'm going to line up 2 of them and take a look. That other one's not on there, and there's pretty much no way I'm getting it on there. So that's when I know that I've made a mistake. I don't just take the average. I don't just wing it. I recount so to make sure that all 3 of those are in the right spot. It's another really good reason why I don't just use 2 dots, because you can always draw a line between 2 dots, but you can't always draw a line between 3 dots. And so if I at least get a 3rd dot in there, I can make sure that all of them are correct. Okay, and so that was the idea of slope today. Rise over run, measuring the steepness of a line, and then we looked at the difference between a positive and a negative slope, which we'll continue to talk about a lot. And we looked at finding the slope of a line that we see in a graph, or drawing a line with when I'm given a particular slope. And that's what your practice is going to be about today.